Good afternoon, everyone, and welcome to today's webinar sponsored and presented by ThermoSoft International Corp, entitled How to Choose a Wood Floor to Install with Direct Contact Floor Electric Heating Systems. My name is Sharon Schaller, the Member Engagement Manager, and I will once again serve as your moderator for today's webinar. And now I would like to introduce our presenters for today's webinar. And first we have Sergey Schlippentak. Has over 10 years experience in the wood flooring industry, especially the heating industry, while working at ThermoSoft. In that time, he has planned, supported, and provided assistance to countless successful floor heating installations. His responsibilities include overseeing the technical support team and acts as the primary contact for the wood flooring industry. Sergey is active on the NWFA Radiant Heating Task Force and on the UL Safety Technical Panel. His number one priority on any floor heating project is to match the desired floor with the right heating system, installation method, control, and end user education to ensure the heated floor can be enjoyed for a lifetime. Also presenting is Ron Oliver. Ron has been in the flooring distribution and manufacturing world since 1983. He has specialized in hardwood flooring, laminate, vinyl, plank, and bamboo for many of those years. He has trained and certified thousands of installers on behalf of hardwood flooring manufacturers. His responsibilities include assisting the technical support team and acts as a contact for the wood flooring industry. Ron is active on the NWFA Radiant Heating Task Force and has sat on other NWFA advisory committees, as well as having been a featured roundtable speaker at the NWFA Expo. Now, without further delay, let's get started with this presentation. Take it away, Sergey and Ron.
And good morning, good afternoon, depending on where you are. In this webinar, we're going to dive a bit deeper into wood flooring and electric systems rather than just heating systems that we've covered in our previous conversations or previous webinars, and more so focused with a direct contact electric and floor heating systems. Ron, want to take it away and go over a bit of our agenda?
Yeah, we're going to have some basic segments: Wood 101, mechanics of moisture content, environmental dynamics. We're going to look at heating basics and overview. We're going to have a brief overview of the hydronic heating systems and electric in-floor heating systems. And then we will, segue from that into direct contact systems electric. So we're going to get into the advantages, why you do it, how to pick the appropriate, floor, how to mate up the right flooring product with the right system, and how it benefits our partners, the flooring retailers, installers, and the consumer.
Exactly. So Wood 101, wood and water. Ron?
We've all been here before, most of us. Wood is a hygroscopic material. At the cellular level, it is going to either expand or contract based on the gain or loss of moisture. This is a concept that everybody's pretty familiar with, but one we have to continue to remind the consumer about.
So there's a number of different wood floor types. As we all know, that there's the solid hardwood, engineered hardwood, and there's also the engineered composite. Ron, do you want to dive into those a little bit more?
Yeah, with the wood product that's been around for ever and ever and ever, good old solid hardwood flooring is still with us and still doing well. And of course, the limitations of a solid wood floor is in its movement, and those are going to affect the performance or the perceived performance of the wood flooring. So it is more of a system where it can freely expand and contract. Engineered takes the basic nature of wood to expand and contract in its width and cross-engineers multiple layers to try and minimize that movement. And then, of course, the engineered composite, which is a newer entry into the wood flooring business, which is a wood veneer on a composite core. Each of these systems have their advantages and disadvantages. So that's the basic things that you need to know about what is being sold as a hardwood flooring product out in the market today. So basically, one of the things that we look at, in this realm is another basic understanding on how indoor, we've talked about the nature of wood. Of course, the indoor relative humidity and temperature control has an effect on a wood floor. So, what happens is when we see, what we see here is two distinct humidity seasons, the heating season and the cooling season. And what happens is when you, especially in the winter, when wood floor seems to have the most difficulty, as the moisture wants to move away from a warmer, drier space to a colder, drier space, and what you end up with is something called vapor drive. So the warm side is moving to the cold side. And what this means is that in the summertime, the vapor drive is from the outside in. And what that does is that raises indoor relative humidity. And in winter, the vapor drive is from the inside out. So what's happening is you now have the summertime in reverse. So what people don't understand is that wood is affected by its the climate conditions that it's in, and those are the dynamics that many times are misunderstood. Any comment on that, Serge?
Not so much, other than when you work with everything together, you have to combine both the heating systems that you have in the space already and the radiant systems that you plan on using, or you need to discuss and plan on the entire dwelling to be planned properly with all systems that may be used. Electric radiant heat, one of the benefits is that it can be retrofit into pretty much any space. But when you put that into those spaces, you have to make those considerations and still look at the heating and cooling of the entire space as a whole. That includes cooling, even though you're putting in the heating system. So a couple of things to mention here when you were talking about HVAC. What is primary, what is sole, what is supplemental? Well, forced air heat, your regular furnace, that is a rapid temperature change. It can get temperatures from one temperature to another very, very quickly. In-floor heat or radiant is gradual. So the idea there is to save the heat that you already have and prevent it from being lost. The two systems really do complement each other, knowing when to use them appropriately. And when you do, you can get quite a lot of benefits out of that. One big thing of note, when you have a properly specified, installed, and operated in-floor heating system, that in-floor heating system combined with your furnace will never be the sole cause of a floor failure. There will always be another factor that needs to be considered when you're looking at a floor failure over a radiant heating system. And the key there is properly specified, installed, and operated. Using things like data loggers, thermal cameras will let you verify that things are installed as they are supposed to be. And this is true for both the electric and the hydronic floor heating spaces. Ron, any comments on this?
No, that pretty much sums it up pretty well. The wood is capable of handling temperature changes and changes in humidity, but they need to be controlled.
In-floor heating 101. We've got two diagrams here that generally show you what and how a heating system works. With a hydronic system, you have your heat source, whether it be geothermal, but ultimately it heats up some sort of a liquid. And that liquid is piped out through the hot pipe, directed through the floor, and it comes back to the heat source to be recirculated once again. Electric systems work a little bit differently. You have a line in the neutral. It could be a 240-volt system where you have a line and another line. But that electricity is supplied to your thermostat, which is then supplied to your heating system and turned right away into heat. So why do people use in-floor heat? Ron?
Well, in-floor heat has been proven to be much more efficient and far more comfortable. Instead of having, a warm upper torso and head and cold feet and trunk, that's actually reversed. And we'll explain a little bit later, how radiant heat does not, you don't lose that heat nearly as quickly as you would with a forced air system. But human comfort is absolutely the key.
So in the bottom right hand of your screen, you have a picture that shows an ideal heat pattern versus a not so ideal heat pattern. If you look at the forced air or baseboard that's shown on the left of the bottom right screen, on the left diagram there, you see that hot air rising up into the corner and into that little peak of that vaulted ceiling and lowering itself down, but it's all the way up in the 95s, 90s at the ceiling level. With a radiant heat system, you're down in the 80s at the floor and 60s at the ceiling. But the main thing is, if you do the entire room, you have an even raising of the heat from the bottom to the top. And at the thermostat level, you kind of end up being at about 65 rather than 75 that you would set with a forced air system. So the benefits of an in-floor heating system, number one, if you're doing a flooring retrofit, you can add revenue to an existing project. Number two, customer demand. And the demand is shown similar with just how big the NWFA guidelines radiant heat section has grown, where it's gone from 1 page to 20 pages. There's a lot of good information in that. So if you have not had a chance to look at the NWFA new guidelines, be sure to do that. Got to throw that pitch in there. And the big one is comfort and property upgrades. Right now, everybody's trying to do something with the market, or not everybody, but a lot of people are. And property values are going up and up and up, and people want to see a value for that in addition to just a dollar sign for the land. So you need to put in those additional comfort features that people really, really want. Electric and floor heating, Ron?
So, the cost savings as we see ourselves as a society moving more and more and more towards a green or carbon reduced footprint, electricity and the generation thereof is in the process of being moved towards a green, a more green approach versus burning fossil fuels. And the cost savings, we're already using an existing power source in the home. The average daily cost is maybe a half a penny per square foot. Reduces your building heat load by up to 25%, saves as much as 40% or more in the energy in your utility bills. It can utilize 100% of the power supplied. And again, back to the concept of more and more renewable sources of electricity. Overall, electric in-floor heating makes sense. Comment, Serge?
Nothing that this slide doesn't already cover.
There you go.
So a little bit of basics about hydronic in-floor heating. Hydronic's been around for quite a while. Hydronic means that it uses some sort of a liquid as the medium to transfer the heat from one place to another. A lot of you have already seen and used hydronic systems in the past, and if you really boil that down, you can cover them as three main categories: systems that are either embedded fully or just at the surface level, systems that are suspended between the joists, and other systems that are in direct contact with the wood flooring itself. Here's a couple of diagrams that show exactly how those systems lay out. Ron, do you want to go over any particular details on these?
Sure. Embedded, will be either fully embedded in the slab or attached to the surface of the subfloor and covered with a cementitious covering, or suspended between the joists, either directly attached to the subfloor or on aluminum hangers. And the direct contact systems where you have channels and hopefully aluminum transfer to get a more even distribution of heat. Sorry about that.
So we're going to compare similar to, the reason we're starting here is to compare how this is very similar to what an electric and floor heating system does. And in-floor electric heating systems really get grouped into the exact same three categories. And the difference is that with hydronic heating, you really have a similar looking system, regardless of who you go with. You've got a water pipe. Electric systems can take on many, many different shapes, colors, looks, and styles. Here's just some of the 10 systems that the NWFA acknowledges. We did break one of them out into two because it's both a matte and an underlayment type system. But these are the different types of looks and how the systems would be installed. As you can see, some systems can be installed in the same with the same system, either as embedded, suspended, joist, or direct contact. Other systems only have one type of installation method that it's allowed. We're going to dive into a little bit what the difference is between line and low voltage. And the one thing that you have to understand when looking at whether it's a line voltage system or a low voltage system is that regardless of which one you go with, the amount of heat produced is the same. A watt is a watt is a watt. So 1 watt equals 3.4 BTU. We'll get into that a little bit later, which means that a system that produces 10 watts is the same whether it's being powered by 24 volt or 240 volt. 10 watts of heat is 10 watts. When you do lower the voltages, which can be beneficial in some installations, you do understand that you have to use more amperage, and that requires a thicker lead wire, similar to what I'm showing in the chart on the right. And you also typically need a transformer when you're going from line voltage to low voltage. The higher the load or the more coverage that you need, the bigger the transformer. And those transformers have their own challenges that need to be considered. Any comments here, Ron?
No, that pretty much sums it up in a nutshell right there.
So with the three different types of general systems, here's a couple of diagrams of how they're placed. You either have an embedded system, which can have either a surface level of concrete or fully embedded in a cement slab. You have the direct contact where you've got your subfloor wood or cement on the bottom, your heating system in between the two, and the wood floor covering on top. And then the underfloor between joists, the black bars on that bottom diagram are the ones that show the type of heating system that is stapled between the joists and then packed in with insulation right underneath the subfloor itself with the wood floor on top of that.
And again,
So,
the three basic categorizations of heat, the same that you would find in hydronic.
Exactly. So diving into a little bit more detail, here's the 7 different systems that can work as an embedded system. Each system has a different amount of type of installation instructions that you have to follow. So reaching out to the manufacturer or following and reading the manual is critical to do that. Some systems are easier to install, others are a little bit more difficult. And there's a couple of systems that you may have seen that are not listed here, particularly systems that use some sort of a membrane, as those are not acknowledged by the NWFA guidelines. Plus, they create a challenge by having a vapor barrier property that can cause issues if installed incorrectly. Ron, you want to talk a little bit between joist systems?
Yeah, and what we're seeing here is we're seeing a couple of systems we have already seen. Some of the systems have multiple applications, but what we're seeing here again is placing the heating element in direct contact with the subfloor. And now the heat is radiating up through that wood subfloor and into the wood floor covering itself. So there is more resistance and more mass that needs to be heated in this and the previous slide. And Serge will talk in a minute regarding direct contact. But again, direct contact, you'll see a couple of the same systems that can be installed embedded, suspended between the joists, or in direct contact, or a version thereof. Some that are consider themselves direct contact. The floor, if it's being floated, would require a pad. So, that would be the minor difference. Anything to add on that, Serge?
Nope. Let's just dive into the direct contact systems. So direct contact systems, you have the multitude of different systems and different looks of that they come available here. And what you need to consider when you're doing with the systems is the different installation methods that come with each particular system. Certain systems here will require, as Ron mentioned earlier, a pad above the heating system itself. Others require a pad below, which can potentially add additional vertical deflection. Ron, any comments you want to mention on these before we dive a little bit deeper into that?
No, go ahead, Serge.
All right, so direct contact electric systems. Some of the big advantages of electric systems that are in direct contact are they're faster to install, usually done with the same day as the flooring is going in. Because they're done so much faster, you're usually getting a lot fewer possible installation errors. You get easy retrofits. They work for pretty much every single room that you can put them in. You can heat just a section of a zone, or you can do the entire zone. And you can place them directly under the floor covering. One of the big things with direct contact systems is that you eliminate the requirement of having to put it into a cement. By eliminating that particular requirement, that's what saves you a lot of time and trouble with the installation that would normally add a week to 2 weeks of installation time frame there. Any type of heating system that doesn't need to be hung up between the joists doesn't require opening the ceiling there and potentially having a sag in the system if there's an incorrect installation, causing a loss of efficiency. And with any direct contact system out there, you're actually putting the heating system directly and the controlling sensor directly in the floor level. So any comments there, Ron?
Yeah, I think the most important thing is coming in the next slide. But again, ease of installation and simple retrofit and control. You're with a direct contact electric system, you have an opportunity to use less energy and control the application of that energy far more effectively.
So some of the big differences between electric and hydronic, and this is shown in the diagram on the left here, is the spacing of the heating element versus water pipe. Electric heating systems generally have a lot more surface area that touches the floor covering itself, especially direct contact systems, compared to a hydronic system, meaning that the amount of heat that's produced is not any hotter than hydronic systems if they're properly specified, but it's a lot more gentler, up to 4 times smaller distance between the heating elements and the as spaced on a hydronic system means that the heat distribution is a lot more even and doesn't need any type of transfer sheets or spread additional items that spread the energy from the heating element over to the floor covering. Ron, any comments here?
Yeah, generally you hit the nail on the head. Since your tubing is further apart, the actual heat being generated is generally quite a bit higher in application. Are you going to get into the diagrams on the right there, sir?
I was going to leave that to you, unless you want me to play a little video here in the bottom corner.
Okay.
Which it's not actually. We're having a technical difficulty with that little video, so we're gonna skip over that one.
We're gonna have to skip it. So basically, this a recap of what we had seen earlier was reduce air infiltration, exfiltration. Again, in the photo, you can see all the heat loss occurring at the windows and in the walls there, in the ceiling. And what you're with this individual room operation shows is as the floor heats, it's a thermal camera. You actually see that the floor gets warm, but the walls don't get heated up. So again, you're moving away from blowing all that heat against the walls and letting it radiate up into the room to be absorbed by the items in that room. I think what we didn't touch on earlier is one of the key comfort effects is as people walk on an in-floor heating system, their feet become warm and their circulatory system brings that heat to their torso. So it's not your skin it's not so much the skin trying to absorb heat from the air. Your body is actually absorbing that warmth. It's extremely comfortable.
So again, just a recap of all the different direct contact systems. Different systems that are available there are dependent on where you're going to install them in the assembly. In all of these cases, you would put the system directly under the floor covering itself. In some cases needing a pad, a vapor barrier, or a combination of the two. When looking at all the direct contact systems, there are a couple of things to consider for the entire assembly structure that you have there. Number one, to make sure that the heating system complies with the wood flooring manufacturer instructions, and that means the padding requirements, vapor barrier requirements, also follows the NWFA guidelines to make sure that it doesn't add those. But at the same time, everything that the installation process goes with those requirements has to abide by the manufacturer of the heating system's installation requirements. And those are making sure that if they require a layer of cement, it's not one of these systems. When do you have to make the electrical connections? Are you doing that in the field, on site, or is that done in the factory? What gauge of wires are you doing and how are you doing your circuits? Can you shorten the mats or do the mats not need to be cut? A lot of electrical systems do not allow the heating system to be cut. You basically jigsaw the puzzle into the space and put it down. Other systems, if you cut them, they will work, but they will have other considerations that need to be addressed, like additional Capcom tape seals, vapor barriers above, below, or connections to lead wires that need to be adjusted accordingly. All of that is something that your in-floor heating system specifier can help out with in order to make sure that you ultimately have a successful installation. But some of these things in the grand scheme of the project may add time, labor, and materials that aren't typically considered when sourcing or speccing the system. All of that needs to be considered when you're looking at the project. Ron, any comments there?
Yeah, my 2 cents worth would be to select a system that is versatile and simple. What you're looking for is simplicity. Serge?
So moving on, how to pick the appropriate flooring and what to consider when choosing a heating system. Ron, you want to go over the how to pick the flooring? A little bit of detail on that?
Yeah, you're always, the first line of inquiry is with the flooring manufacturers themselves. You want to know what it is that they recommend and allow. When you're looking at hickory and beech, that will be a little bit of a caution. Some manufacturers with beech products do allow it, others do not. The same applies to hickory, but many cases where this applies that the manufacturer is not comfortable with beech or hickory products being used over a in-floor heating system. And many exotics are excluded by these same manufacturer specifications because the heat can release some of the oils and discolor the floor. So again, those are considerations to make, and you're always going to want to ask your flooring manufacturer whether they allow that or not. When you look at what you want to consider in choosing a heat system, again, that suitability of use approval from the manufacturer, the safety, efficiency, installation methods approvals. Some manufacturers may not agree with how that material would be used. Again, connections made at the factory or in the field, the cost of installation, time, labor, additional materials. Those are all tied back into my comment, the last slide. Look for a system that is simple, because simple is good, and the simplicity of a system can save thousands of dollars in added costs in installation, its cost of operation, and again, have an electrician come out and take a look at the panel and tell you if you have enough juice there to drive an electrical in-floor heating system.
So some of the things that were brought up by the Radiant Heat Task Force when working with the NWFA, and these things are the things that work their way into the new installation guidelines at the NWFA, are some operating procedures, some recommendations, and some limitations. On this slide, we've bolded a lot of the key things that you need to know. Number one, most people feel comfortable between 70 and 80 degrees. From personal experience, myself and my wife, we keep our heated floors at about 73. These are wood heated floors. Most manufacturers don't allow the floor temperatures to exceed above 80, and customers, when they're expecting a heated floor above 80 degrees, one thing to consider is that wood floors don't get installed in a bathroom in a small space where you typically have water, and yes, you do want that floor to be really warm. A wood floor in a larger space, you don't want to be overly hot. You don't want it to be overbearing. As a matter of fact, when you don't notice it is when you're getting the energy savings of having a warm floor and not having to use the additional resources, utilities to heat the space additionally. So you want that floor to be unnoticeably comfortable. Supplemental humidity controls are very often necessary, meaning that you want a humidifier in the spaces or a humidistat to tell you whether you need it. And data logging devices are extremely recommended in order to help mitigate any potential claims in the future. As we mentioned earlier, wood floors that have a heating system below them typically tend to blame the heating system as the cause of the failure when it is not. Any other comments on this, Ron?
Yeah, I think the important point there is, again, when you have an in-floor heating system in a house that experiences problems that are related to just extremely dry conditions, it is the in-floor heating system that gets the blame. My experience in the industry has been that I have seen far more floor failures from extremely low humidity in homes that don't have in-floor heating, but when in-floor heating is involved, that automatically takes the blame. But it's an industry-wide problem that when you have such severe indoor environmental conditions that wood flooring suffers. I have friends who are in the musical industry, pianos, guitars, furniture, they all suffer in relation to excessively dry environments. So I think we're putting that in there as a caveat. That's where the data logger device becomes very helpful, because you can now, it's a check engine light. The homeowner can be warned, hey, you're getting a little dry here, time to react. So I think that's a very important point. Thank you, Serge.
One more thing to notice is wood subfloors and class 1 vapor barriers. The new NWFA guidelines very clearly went into a lot of detail about moisture control. And class 1 vapor barriers are very clearly specified where they can and should not be used in certain applications. Some of the heating systems act as class 1 vapor barriers just by the nature of their construction, being particularly poly and foil mats. Unless they take steps specifically to mitigate that vapor blocking property, those heating systems are use them with a little bit of caution to make sure you install them in the right application and in the right assembly. Now, a little bit of information down below, 1 watt equals 3.4 BTU. The reason we have this kind of conversion here is because a lot of home owners want to know if they can use the system as a sole source of heat or as an only source of heat. As a wood flooring professional, you should not be the one who makes a decision whether this can or cannot be the only source of heat. As a matter of fact, the only people that can really make these types of decisions are the structural engineers and the environmental engineers in that particular geographical area, because they know what that home will require. If this is a retrofit, it's an even harder thing to determine because you have to do a heat loss study, which in some cases includes replacing the door with a blower seal, pressurizing the home to a particular amount, and seeing how much of that pressure is lost through the other open surfaces to know how many BTUs you need. Now, generally, the general rule of thumb is you can have a very comfortable space by using half of the BTUs produced with radiant heat as you would with a forced air system. So in this example that we have down at the bottom with 1,000 square feet, if you have a 60,000 BTU furnace, you will generally have enough heat produced with 1,000 square feet of flooring, because you're producing anywhere from 27 to 40,000 BTU, depending on the system you choose. But if your furnace isn't running, neither is your humidifier. So that brings up the challenges that you have to consider the project as a whole. And choosing a floor heating manufacturer along with the wood floor manufacturer that have considered those kind of things, and talking to them, making sure that everybody gets on the same page and talks, will guide you greatly in making this project a success and make it a lot easier for you.
And contact us at any time. We'll help you.
Yeah, exactly. Give us a call. The NWFA has put out a lot of publications that speak to moisture causes problems and guidelines. So be sure to read the new guidelines as well as the additional publications that were put out, because there's a lot of the information that's in this presentation that's being pulled directly out of there. Ron?
Yeah, this kind of goes back to selection. Again, the NWFA has put out a new information and dimensional change of coefficient. So when you look at certain species like mesquite, chestnut, black cherry, maple, you can see that they have a lower dimensional change coefficient. And you move up to beech and to hickory, and you start to see higher levels, and those can create some concerns. And a lot of it also, their cellular structure suffers in this particular application. Some people look at white oak and red oak, and they're going, "Oh my goodness, I can't use that." Again, the dimensional coefficient is most prominent in hickory and American beech, and seem to be the ones that are the most highly impacted. When you look at imported species, again, Marabou, the CT is very low. Moving up to Sydney Blue, again, is actually higher than that for American beech. So when you're looking at some of the common species that are used, both hardwood, imported woods, or in some cases softwoods, you can see that some of the softwoods are actually extremely dimensionally stable, aside from the fact that they are not as hard in some cases as a hardwood floor. These guidelines are very much in play when you're looking at what to use over an in-floor heating system. Anything to add, Serge?
Just the fact that even though the oaks are at the bottom of this list, we have done countless jobs. Personally, my own house has a white oak floor, which it is an engineered floor. It is white oak with a white oak veneer and with zero issues. So The biggest thing is humidity control, humidity control, humidity control. We've even had the hickories, and we've even had projects that were done with hickory that have not had problems, but these are the houses that really do spend the time controlling humidity, because the biggest change is that you see the dimensional change coefficient. The way that it really impacts above a heated floor is how long it takes between having a problem and the problem manifesting itself with a problem with the floor. The higher the coefficient, the more readily that floor will show that change.
Correct.
So some of the benefits of these types of heating systems for retailers, installers, and customers. When you take a look at a traditional electric system versus a direct contact system, traditional systems will require some sort of a layer of cement to be embedded in there. With a direct contact system, they're simpler to specify because you don't have those additional layers. There's fewer trades to manage for the retailer to dealer to get the installation done faster, and you generally have a faster project completion. In turn, the customer ends up saving the money not so much on the material costs, because direct contact systems do typically have a higher cost per square foot of the heating material itself, but the amount of support materials that are needed for it and the amount of labor that it takes to put it in will generally result in close to a 30 to 40% savings, depending on the system you go with, compared to a traditional system. Faster project completion. Again, the homeowner gets back into their house quicker because electric systems are most often used at this time in retrofits or truly new spec construction where you have electricity as your primary source of heat. California has been very prominent in electric systems because of the requirement of the solar panels. Anywhere else where you have really cheap electricity, electrical systems are very often added into there. And again, fewer installation errors, so less problems and less claims for the manufacturers, less claims for everybody to deal with. Ron, any comments on this?
Yeah, everything is about understanding, and some of these systems actually lend themselves to being placed by the floor covering installer and then connected to the electrical system by a certified electrician. So again, some of these systems offer the installer and the retailer the opportunity to take control of this application as opposed to an HVAC contractor.
So we had one more poll question. Did you know about direct contract systems before this webinar? Yes, please do throw an answer down into the chat or the Q&A section. But that's generally the end of this webinar. We're going to go through a quick summary. We broke this down into 4 steps. The first step is check and choose the floor covering first and foremost. Once you choose your floor covering, see what is compatible with an electric system and choose your installation method of how you want to put down that heating system. And once you know your floor covering and your installation method of how you want to install that floor covering, then go and find a heating system that will be compatible with that. If you can't find those, go back to step 1 and choose a different floor covering. Now, you can do more of these on than in one step. As for us, we've actually been working very closely with a number of floor heating manufacturers to make sure that they are listed or they are familiar with the systems that we manufacture, and in some cases endorse those systems because of the simplicity that they provide. In other cases, we come together to a consensus that these systems are not appropriate for an installation. And as in general in the wood floor space, sometimes the best job that you do is the one that you don't take. So we want to make sure that ultimately every project succeeds. And the most important thing at the very end is install and document properly, or properly document pictures, readings, and follow the instructions of everything that the every manufacturer in the group
Requires.
provides, requires. Ron, any comments there?
No, that's I think pretty much speaks for itself there.
So that brings us into the Q&A.
Thank you, Sergi and Ron. That was a great presentation. Good information to know. So we're now going to open it up to questions submitted during today's presentation. So you still have time to type in your questions in the questions pane of your control panel, and we'll get right to that, or Sergi and Ron will answer all those questions for you. So good time to ask anything you need to know about radiant heating and get your answers to those questions. So I do have a few questions, Sergi and Ron, that were submitted prior to this. Let's get started with those questions. The first one, are there any wood floor manufacturers that approve installation of direct contact electric heating?
So in our experience, we've actually worked with a number of manufacturers that approve them. Hallmark Floors has released a new radiant heat guide that is a great read and good to get checked out. Johnson Hardwoods is on there. Mercier, Lausanne, and Mirage are all in works of getting this taken, exploring these systems. So reach out to their technical support for updates in the near future. Owens as well has recently accepted the warm step systems as a similar to what Hallmark did as part of their lineup of what they allow.
So more and more manufacturers are starting to line up and understand and accept in some cases specific types of electric in-floor heating systems for use with their floors.
Okay, we have another question. Is there an electric system that is universally compatible with all common installation methods?
As a matter of fact, yes. That is one of the systems that we manufacture. It's called WarmStep. WarmStep allows installation with either a floating method, which was the old version. It allows a glue down method, which in this case actually is a glue through method, because what you would do is you'd put down a layer of glue on the subfloor, as well as putting down the mat into the heating system, as well as a layer of glue above that and the floor down, all in one step. And it does allow for a nail down application, and it has been tested that it works well with that by power nail.
Okay.
Ron, any comments on that, or?
Yeah, again, what I addressed earlier is simplicity, being able to float, being able to glue, being able to nail, and we also have methods for glue assist nail down methods as well. So again, in that particular case, all of the installation bases got covered.
Okay, is electric in-floor heating safe?
So every reputable electric heating system will carry some sort of a third-party safety standard testing. That can be UL, CES, TUV, ETL, any of those parties are all testing the system to a particular standard that applies to in-floor heating. A lot of the requirements for those installation systems, for those systems, require embedding it in a layer of cement, some sort of either 3/8 inch or thicker coating of that. That is done to allow a non-flammable surface to be in touch with those types of systems. There's additional testing that is done for systems that contain things like a thermal cutoff, similar to what WarmStep is, and that is what allows that system to be safe under a wood floor without having to have that cementitious material, as well as properly limited power outputs that are tailored for the application in play. You see a lot of heating systems out there that are general systems that are sold by a lot of places, a lot of different companies that look similar, and those systems get shoehorned into an application that doesn't always apply to the entire process. We all know that in construction, it's, oh, well, I've got this on a truck, let's make it work. Heating systems don't tend to work that way. you want to make sure that you work with a company. ThermoSoft in particular has been around since 1996, and we've been doing heat since 1996, which is one of the reasons we have 9 different heating systems that we offer. I'm sorry, 7 different heating systems that apply to 9 different categories that the NWFA acknowledged there, but we only really sell one for wood. There's a right application for the right project. And that's what you want to make sure to use to make sure that it's safe.
And this is the system that's most applicable to a wood floor.
Okay, we have another question. Are low voltage systems safer or better than line voltage systems?
Neither to both of those questions, to both of those points. As I mentioned earlier in the presentation, a watt of heat is a watt of heat. So a low voltage system that produces 8 watts per square foot is going to be the same thing as a line voltage system producing 8 watts per square foot. The difference is the additional materials needed around the low voltage system and the difference in wiring that a line voltage system will take. In some cases, a low voltage system, depending on your power source, may be beneficial for you. But in a lot of cases, the line voltage systems, the ones that get powered directly off your home's already existing power line, are a lot easier to use, install, and operate.
Okay. And why are most electric in-floor heating systems embedded?
As we've touched on that a little bit earlier before, the UL, ETL, the safety standards require, depending the construction of the heating element, may require a non-flammable material to be in direct contact with it, which is in most cases a cementitious material. That's why you want to use for direct contact systems that account for that element and allow you to save the headache of having to put down all that cement.
Okay. We have a question from Mark. He asks, are the systems able to work with LVP materials?
Yes, they are when you're looking at the classification of a rigid or SPC type of core. I think is that the question you're asking?
And for a little bit more detail on the LVPs, Metro Floors, as well as Hallmark, has a number of lines that they've already tested with warm step specifically that would work and have approvals, warranties, and everything.
And to answer your question, Mark says yes, Ron. So
okay.
Thank you.
Yeah, because the main, what we're seeing in the wood flooring business is, wood veneers being married to that type of composite core. And, the higher aggregate counts make it a little more dimensionally stable when applied over in-floor heating.
Okay. How can a glue assist be achieved if you only apply a few beads of adhesive on the material?
You want me to take that one, Serge?
That's the unique property of warm step, particularly. With warm step, you would do a full spread on the bottom, put the warm step mat into that full spread that you do with a 1/8 inch sawtooth trowel, and then you put the bead on the back of the board. Ron, you wanna talk about how?
Yeah, that's actually an excellent question, one that we get quite a bit. And since the mat, can breathe, what's happening is I like to call it the primer coat of adhesive under the mat now marries itself to the bead of glue that you're putting on the bottom of the plank. So now, since you can also see the heating element so clearly through the mat, you just go ahead and, nail down as planned. So again, kind of a little bit of a hybrid, but, definitely using a lot less glue than you would use in a full spread, what we call glue through or a double glue down.
It's right close to, but I think we have time for one more question. From Patrick, he says, good point about a dehumidifier installed since no furnace. He says, what system would you advise to install?
Without a furnace?
With no furnace, I take it, yes.
So if
Well, I
there's
know.
furnace, go ahead, Ron.
Well, I know. Several HVAC companies make standalone humidification systems. I know April Air worked very closely with the NWFA over the years. There are whole house humidifying systems that can be installed and can supplement the use of an HVAC system.
One thing to consider a electric in-floor system is that you can zone each room. Most systems will limit no more than about 400 square feet per a thermostat. Generally, at the 120 volt operation, you're looking at about 150 to 200 square feet, 200 for warm step, meaning that every room has every 200 square foot room has its own thermostat, which may need either its own little humidifier or monitor there. We do have thermostats that are coming out for the lineup that actually monitor humidity, relative humidity in the space, as well as the temperature of the floor, and send notifications as needed. So that's something that's very, very helpful to the homeowner when properly educated.
All right. Well, it is at 3:01 here. We are going to go ahead and close it out. Do you want to share your screen with your information, contact information? Thank you very much.
Absolutely.
Thanks, Sergi.
While that's up there, Sharon, if there's another question that we can answer without jumping off the screen, we'll gladly take it because we've got a little bit of time here.
Okay. There's just not a question, but there's a comment. What it says from Jean, it says, one should know the big difference with an engineered floor with a veneer and another like ours with a 4mm lamella. The lamella puts a lot more stress on the substrate, and the species like Jatoba and hickories, etc., are just too powerful and will react by splitting instead of containing the stress like a thin veneer does.
Yeah, they overpower the engineering of the product because of that thick lamella. And
that is absolutely the case, yes.
And humidity control with a thicker lamella is actually more critical than with a thinner lamella because, as Serge talked about earlier, those thicker lamellas have a tendency to begin to move, and it's those thicker lamellas that also have problems, during the heating season with environments that are too dry.
Okay, Jared has a question. Will warm step work in a large bathroom under tile and solid wood?
You don't put wood in a bathroom.
A, don't put wood in a bathroom, but B, tile systems have applications or have systems that are designed for tile to allow for a much quicker and better grab of your mortars. The thermotile system that we have, and Jared, we can connect offline, is designed to just be placed down, thin set, and tiled right over the top without having to need any additional layers. With a warm step system, because of its nature of it being a pad, you have a separation layer there between the mortars, and you have to do multiple layers of mortar. So it's not approved for that. Plus, wood floors need a much more gentle heat, unlike the stone and tile spaces. So warm step isn't quite applicable for the tile space.
Good to know. Okay, well, thank you, Sergi and Ron. Thank you, everyone, for attending today's webinar, sponsored by ThermoSoft. Appreciate your advice and your expertise in this area.